In this connected world, the proliferation of intelligent devices has created a market for entirely new solutions. IoT will blur the boundaries between virtual and physical objects and enable seamless connectivity across devices, things, and humans. Organizations are finding innovative ways to harness this data, using it to drive decisions, enable new services, business models, and reduce costs. There are many opportunities to extract value from data that result in significant improvements across industries such as automotive, industrial manufacturing, smart utilities, oil and gas, high-tech and professional services, etc. Critical machinery, once deployed on the field, is expected to work with minimal failures while delivering high performance and reliability. In typical remote monitoring and industrial automation scenarios, although many physical objects from machinery to equipment may already be smart and connected, they are typically operated in standalone fashion and not integrated into existing business processes. Internet of Things adds an interesting dynamic to remote monitoring in industrial automation solutions, in that it allows equipment to be monitored, upgraded, maintained, and serviced in ways not possible before. This demo showcases how the health of remotely deployed machinery can be monitored to illustrate how data coming from devices can be analyzed in real time, integrated with backend systems, and visualized to initiate action as may be necessary.
Now let's look at the overall setup of the demo. The temperature sensor is connected to a Raspberry Pi via a USB interface. The Raspberry Pi acts as a smart gateway and has Java embedded suite and the Oracle event processing embedded running on it. The Raspberry Pi is hooked on to a router via its Ethernet port. The router is connected to the backend server and creates a private Wi-Fi network for mobile devices to connect. The backend server running on this laptop has Oracle Event Processing, Oracle SOA Suite, Business Process Management, and Oracle Service Bus, all running on WebLogic server. All the information is accessed through an iPad running an Oracle ADF mobile application. It can be any mobile device, such as a smartphone or a tablet. Alright, now let's get into the demo. First, I'm going to log in as the operations manager. So in this screen, I see all my facilities, all my warehouses. I see the location and the current statuses. Currently, both my locations show a status of green, so that means nothing to worry about. On the bottom of the screen, you also see a live streaming chart. I see real-time temperatures coming in from my gateway device. My Raspberry Pi, acting like a gateway device, sends the temperatures to the server side, and the iPad app pulls those temperatures from our server. So as now you can see the temperatures coming as a flat line. There's no fluctuation. So let's see what's going to happen when I dip the sensor into a cup of cold water. Now remember, we have threshold set on the gateway, and there's going to be first level of alerts triggered by the Raspberry Pi. The first level alerts are sent to the server side, and then if there's sustained level of alerts, our OEP enterprise will send alerts again. So now, because we have sustained a drop of temperature, one of the icons on the locations have already changed to a warning sign. Now let's go into that location and see what's going on there. So in this screen, you still have the real-time temperatures coming in. We also have two lines, set at 60 to 80. These two lines signify the threshold that's currently being placed on the Raspberry Pi. Because the temperature breached the 60 threshold, we're getting alerts. You can also see the alert details. So these are the sustained alerts generated by the OEP at the enterprise side. You also have the two options on the bottom. One thing you can do is to update rules. So what this screen allows you to do is that you'll be able to change the threshold that's set on the gateway device. For example, it's now set to 60 to 80. I think that's could be a little too stringent, so I'm going to expand that rule to a bigger band. And once you tap on the submit button, it'll send a command to the Raspberry Pi, update the threshold. So now OEP embedded would no longer use the old threshold, but detect temperature fluctuations based on the new rule. Now you can see the two lines have expanded to the new numbers we've set in the previous screen. Now everything in between these two lines will no longer trigger any alerts. Because we've built integration from OEP to BPM, and we have got a sustained alert from OEP, the process is automatically triggered to have a task created under your workflow. So go to this screen. You have our timestamp right here. This is the temperature that triggered the task. So all this screen is showing information pulled from the BPM application. You see all your tasks on the left, task details on the right. And as a manager, I have some visibility into what else is going on at my location. For example, I can see what kind of services has been done. I can see what probably is overdue to help me make a better decision in terms of what to do with this alerts. It's also an opportunity to integrate with your enterprise applications, for example, your content management service. In this case, maybe I want to see what kind of invoice or records have been entered into a system based on the previous services. In this case, I could directly close the task, or I think I'm going to ask someone to look into it. So I can go into assign. I can assign this to a technician. And what this does too is that it talks to the BPM system and reassigns this task from your task list to the technician's list. So now I can see that task disappears from your list. And I'm going to log out and re-log in as a technician. So as a technician, I still have the same visibility in terms of what kind of services have been done. I can also look into troubleshooting. For example, we can potentially do remote diagnostics on the equipment. If you have not just a temperature sensor on the device, but if you have other types of sensors, for example, a motor sensor, you can tell what else could be going on and causing the temperature fluctuation based on the motor throughput. You can also check the power supply, see if that's the cause. You can check the ventilation conditions, see what kind of what else is going on around. So now I have to see a flickering light near one of my fans, so I think maybe there's something wrong going on in that area. You can even choose to upgrade the firmware remotely. If all that doesn't help you, you can also go into in-person diagnostics and follow the set of guidelines to help you diagnose the problem on site. If you could resolve the issue remotely, or you've appeared on site and figured out what's wrong, you can close the task right here and to go click resolved. But one last thing I'm going to show you is replacement part. Maybe throughout the diagnostic process you've identified a faulty part and you want to place a replacement order. We want to be able to directly place the order in the iPad app, and this shows a wonderful opportunity to directly integrate this with your ERP system. This screen shows you a BOM overview of some of the equipments of the device. For example, in the previous screen we've seen the motor throughput isn't very ideal, so I'm going to add this motor to my shopping cart. I have a shopping cart experience right here in the same app that I use to diagnose and identify the problems. I can add multiple components to my cart, and when I go to place order, all this information can be saved in my ERP system, for example, Oracle E-Business Suite. I click continue. And now because this task is now pending order fulfillment, it is removed from my screen and I'm no longer assigned to it. So that's the end of the demo. Thank you.